Ethics and IoT devices vulnerabilities. The nation's morals are like its teeth. The more decayed they are, the more it hurts to touch them. George Bernard Shaw. This section discusses various vulnerabilities and weaknesses in IoT devices that are sometimes associated with ethics failures on the part of device manufacturers. 1. Weak or hard-coded passwords. Many IoT devices come with preset usernames and passwords that are easy to guess or find online. Hackers can exploit this vulnerability to gain access to an IoT device and exploit device data and any controls provided by it. Unauthorized access to devices is facilitated when end users fail to change the factory-designated device passwords. 2. Vendor accountability. Another issue is vendor or manufacturer accountability. Not all manufacturers and vendors of IoT products are trustworthy or remain accountable for their products after the sale. Some may be strictly profit-motivated, resulting in poor quality products with weak safety features and no after-sale support. Some device manufacturers may be associated with data-stealing organizations whose primary interest is to collect and harvest user data. 3. Case in point. In 2020, security researchers uncovered a flaw in components made by Thales, a manufacturer of millions of connected devices. The IoT vulnerability can be remotely exploited, allowing a hacker to take control of the device or access the network. Thales manufactures components for millions of devices used by thousands of companies. To its credit, Thales subsequently released a patch for the flaw. 4. Lack of encryption. Some IoT devices do not encrypt data during transmission. Failure to encrypt makes it easier for hackers to intercept and eavesdrop on sensitive information. 5. Case in point. A 2019 study examined communications traffic sent to and from IoT devices. The study found that the vast majority of IoT transactions were occurring over plain text channels instead of the more secure SSL encrypted channels. 6. Case in point. In 2023, Anker, the company that produces UFI cameras, admitted that its security cameras are not natively end-to-end encrypted. The cameras can and did produce unencrypted video streams for UFI's web portal. The company now states that they are working to correct the issue. 7. Outdated devices and software. Outdated devices and/or software are sometimes issues with IoT. Manufacturers may fail to update firmware for their products. Firmware that is not updated may leave devices vulnerable to exploits and attacks. In some cases, old and outdated software is just left in place due to the inconvenience and expense of updating something that appears to be working efficiently. In other situations, entire companies are sold or go bankrupt, leading to abandonware and/or discontinued service. 8. Case in point. In ZDNET, tech reporter Jason Perlow provided the following reviews and comments about outdated and abandoned devices. First, it was Ether's smart speaker, the Comb. Then, it was the Google Revolve Smart Hub. Then Netgear's connected home wireless security cameras, ViewZone, was killed off. Then it was the Jibwa cloud-connected robot. And while it's not rendering the products into e-waste, Google is cutting off the works with Nest functionality. Perlow goes on to state, it seems like every month, an Internet of Things device becomes abandonware or less useful after its cloud service is discontinued. 9. Insecure APIs. An application programming interface is a set of defined rules that enable different applications to communicate with each other. Weaknesses in the APIs used by IoT devices can allow hackers to bypass security measures and manipulate the device. 10. Inadequate authentication and authorization. IoT devices may lack proper authentication and authorization mechanisms, allowing unauthorized users to access and control the device. Multi-factor authentication and authorization applications should always be considered for the protection of devices and user data. 11. Physical tampering. Sometimes IoT devices are physically accessible to others when left unattended. Hackers can sometimes exploit this inattention by tampering with the hardware, stealing data, or by exploiting connected unauthorized peripheral devices. 12. Case in point. A famous example of a device being left unattended and then hacked involves the case of FBI agent turned Soviet spy Robert Hanssen. In 2001, when then FBI agent Hanssen left his Palm 3 PDA device unattended in his office, it was snatched and examined by another agent who had been tasked with investigating the unwitting Hanssen. Data from the device was subsequently retrieved, and the device was quietly returned to the location where the unsuspecting Hanssen had left it. Data extracted from the device was later used as evidence against Hanssen, and he was subsequently sentenced to life in prison and died there in 2020. 13. Device manipulation. IoT devices can sometimes be made to operate in ways that are unintended by the device owners. Software that controls a device can be surreptitiously modified, causing the device to fail. 14. Case in point. A famous case of an IoT device being manipulated through malware involved centrifuge devices in an Iranian nuclear power plant. In 2010, it was discovered that government operatives believed to be from the US and Israel secretly modified software controlling the centrifuges, causing them to fail. The Stuxnet malware event was noteworthy as a first known cyberwar incident involving international adversaries. The case raised questions about the ethics of such activities. 15. Lack of secure boot. Secure boot is a security standard to help make sure that a device starts up using only software that is trusted by the original equipment manufacturer. Without a secure boot process, attackers may be able to modify the device's firmware and install malicious software. 16. Poorly secured communication. A communication protocol is a system of rules that allows two or more entities of a communication system to transmit information via any variation of a physical quantity. The rules should be developed in order to provide security for the senders and receivers of the communications. Insecure communication protocols may be intercepted and manipulated by attackers to execute various attacks. 17. Distributed denial of service attacks and botnets. A botnet is a group of internet-connected devices, each of which runs one or more bots. A bot is a software application that runs automated tasks over the internet. Botnets, or group of bots composed of many compromised IoT devices, can be used to launch powerful distributed denial of service attacks. In a DDoS attack, the high volume of data reaching the targeted victim's server overwhelms the victim's system and drastically slows or completely stops legitimate communications to and from the device. 18. Lack of user awareness. Lack of user awareness can be a vulnerability for IoT users. Users may not be aware of the risks associated with IoT devices, leading them to make poor security decisions or not update their devices regularly. 19. Summary. The Internet of Things sometimes has vulnerabilities and weaknesses that are associated with unethical implementation and practices. These vulnerabilities can include weak or hard-coded passwords, vendor accountability, lack of encryption, outdated software, insecure APIs, inadequate authentication and authorization. Physical tampering, lack of secure boot, poorly secured communication, distributed denial of service attacks, weak physical security, and lack of user awareness. These vulnerabilities can be exploited by unethical hackers to gain access to an IoT device, exploit device data, and manipulate devices. To address these vulnerabilities, users should consider multi-factor authentication and authorization applications, secure boot processes, and secure communication protocols. Manufacturers should release regular firmware updates, use proper encryption, and implement proper authentication and authorization mechanism.